going to calculate moles and particles for our lab from last week. Start with the mass of a nickel. The mass of the coin nickel is going to go right here. I'm just going to call it M. In order to find the mass of the nickel in the nickel, it's 25% of that. I'm going to multiply that by 0.25, and that's going to give me the mass of nickel in the nickel. Now I need to change that to moles. The molar mass of nickel is 58.69. So I'm going to take my mass in grams, and if I look at my mole map, I have to divide by the molar mass, 58. And I've already forgotten, 0.69 grams in 1 mole. That'll give us the moles of nickel. We'll take that answer down, nickel moles, and we'll multiply by the molar mass, 6.02 times 10 to the 23rd atoms in 1 mole, and that will give you atoms of nickel. Now, next, we're going to do mass of copper. So again, we're going to take the mass of the coin. 75% of that coin is copper. So 75% of the mass will be copper. To find the number of moles, we'll take copper grams, change it to moles by dividing by the molar mass of copper, which is 63.55. And that will give you moles. That will come down here. Find the number of atoms, we'll take our copper moles times molar mass, or not molar mass, Avogadro's number. And that will give us atoms of copper. All right. Water. To calculate the molar mass of the water, we started with how much water. Should have been around 30 grams. So I'm going to call that mass of water. To calculate the molar mass of water, first of all, I just read that wrong. Molar mass of water, you've got 2 hydrogens plus 1 oxygen, gives you 18.02 grams per mole. Now, for B, we'll take the mass of the water, and we will divide that by 18.02 grams in 1 mole. That's going to give us moles of water. To find molecules, we'll take moles of water and multiply by Avogadro's number. All right, for table sugar, calculate the molar mass of sucrose. So we'll go to the magic calculator. C12H22O11 has a molar mass of 342.3. 342.3 grams in 1 mole. Calculate the number of moles of sugar. So we'll take the mass of the sugar and we'll divide by 342.3 grams in 1 mole. That will give us moles of sugar. That answer will come down here and get it multiplied by Avogadro's number. And we're calculating molecules, and that will give you molecules of sugar. Now, the last bit, calculate the number of atoms. So whatever our value is from here, this is for molecules of C6H, not C6, C12H22O11. It's asking for atoms of carbon. So we're going to take this answer. How many carbons are in that one molecule? There are 12. So we're going to multiply our answer by 12, and that will give us carbon atoms. Chalk. Using what we learned about naming chemicals, which we haven't done yet, write the formula for calcium carbonate. Hopefully you remember CaCO3. If you don't remember that, hopefully you Googled it. What's the molar mass of calcium carbonate? Calcium CO3, 100.09. 100.09 grams in 1 mole. Calculate the number of moles of calcium carbonate used in the signature. So you're going to take your value from up here, and that mass of the signature divided by 100.09 grams in 1 mole will give you moles of signature. And then calculate the number of oxygen atoms. So now we're going to have to convert to molecules. So we're going to take the moles of the signature and we're going to multiply that by Avogadro's number. That will give us molecules, and just like before, how many oxygens are in one calcium carbonate? There are 3, so we'll multiply by 3 oxygens in every 1 molecule. Molecules cancel and we'll end up with atoms. All right.